Hi Albert, this is Professor Megan Bunnell. I got your question on the Unit 7 check-in assignment, and I thought I'd create a short video explaining question 9 on your Unit 7 homework. A video just might be better than typing out the problem. So let me know if this helps, and if it doesn't, send me an email and we'll try a different method. So this question is 2x squared minus 3y squared equals negative 19, and 3x squared plus 2y squared equals 30. And the problem asks us to solve using the addition method. So the addition method means that we need to add these two equations together to eliminate one variable. So we either want to eliminate the y variable first or the x variable when we add these two equations together. Now, if we add them together now, the variables will not cancel out. So we need to multiply the equations by a factor so that when we add them together, the variable can cancel. Now I'm going to choose to cancel the y squared variable. So that means I'm looking at negative 3y squared and positive 2y squared. And when I add these two values together, I want them to go to 0. So I need to figure out what I have to multiply the negative 3 by and the 2 by so that when I add them together, it goes to 0. Now, the least common multiple between 3 and 2 is 6. That's because 3 times 2 is 6, and then 2 times 3 is 6. So I'm going to change both of these y squared terms so that the coefficient in front is a 6. In order to do that, I need to multiply the top equation by a positive 2, and I need to multiply the bottom equation by a positive 3. So when I do that, for the top equation, I get 4x squared minus 6y squared equals negative 38. You want to multiply the 2 by each term in parentheses. Now we're going to do the same with the bottom equation, and we'll multiply 3 by each term in parentheses. So 3 times 3x squared is 9x squared. 3 times a positive 2y squared is a positive 6y squared. And then 3 times 30 is 90. Now I'm going to add these equations together. And I can add each of the common terms together, and hopefully the y squared terms will go to 0 and cancel out. So 4x squared plus 9x squared gives you 13x squared. 6y squared, and negative 6y squared plus 6y squared goes to 0, since the negative 6 plus a positive 6 is 0. So those go away. And then negative 38 plus 90 is 52. Now, if you'll notice in this equation, I only have an x variable. So that means that I can solve for x since I only have one variable in the equation. To do that, we're just going to multiply both sides by 13 to isolate the x squared term. And you get x squared equals 52 divided by 13, which is 4. Next, you'll take the square root of both sides. And when we take the square root of the 4, we're going to put a plus minus sign next to it. So the square root of x squared is x, and the square root of 4 is a positive 2 or a negative 2. Okay, now that we found that x equals 2 and x equals negative 2, we're going to take those values for x and plug them into one of the original equations and solve for y. So we have to do this with both x's. First, we're going to choose x equals 2 and solve for y. And I'm going to choose the top equation to plug in the 2 for x. You can also choose the bottom equation, it doesn't matter. So I'm simply going to take the 2 and replace the x with a 2 in the top equation. So I have 2 times 2x squared minus 3y squared equals negative 19. And I'm going to solve for y. So first, 2 squared is 4. So this becomes 2 times 4 minus 3y squared equals negative 19. This is an 8. And then we have minus 3y squared equals negative 19. So again, we want to isolate that y squared term, so we'll subtract 8 on both sides. We get negative 3y squared equals negative 27. Now we'll divide both sides by negative 3. We get y squared equals a positive 9. It's negative divided by negative is positive. And then we want to take the square root of both sides. And we get y equals 9 and y equals 3, because the square root of 9 is 3 and the square root of 9 is negative 3. So y equals 3 and y equals negative 3. Now what does that mean? That means that when I plugged in an x equaling 2, I got y equals 3 and y equals negative 3. So that gives me two ordered pair solutions. My first ordered pair solution is 2, 3. And then the second is 2, negative 3. So here I have two solutions. Now I'm going to plug in a negative 2 for x and solve for y and get some more solutions to this problem. Alright, so I'm going to do this whole process again, but now instead of x equaling 2, I'm going to do x equals negative 2. So wherever I see an x, I'm going to plug in a negative 2. And I'm going to use the top equation again. You can use the bottom equation and you'll still get the same answer. So I'll just substitute the negative 2 for x, so I get 2 times negative 2 squared minus 3y squared equals negative 19. And then negative 2 squared is a positive 4, so this becomes 2 times 4 minus 3y squared equals negative 19. 2 times 4 is 8, and then I have 3y squared equals negative 19. I'll subtract 8 on both sides, and you get negative 3y squared equals negative 27. We'll divide both sides by negative 3. And we get y squared equals a positive 9. Again, you'll take the square root of both sides and you get y equals negative 3 and y equals positive 3. So that tells me that when I plugged in a negative 2 for x, I got y equals the positive 3 and I got y equals a negative 3. So I have two other ordered pair solutions. I have negative 2, 3, and I have negative 2, negative 3. Okay, so the answer to my entire problem is these 4 ordered pair solutions. So my answers are 2, 3, 2, -3, -2, 3, and -2, -3. And just to recap, this is my final answer, and I found this by using the addition method, and we first solved for x. Once we found our 2 values for x, we plugged in each of these values one at a time and solved for y, and we found ordered pairs. And these were the final 4 ordered pairs that we found, and these are our solutions. Let me know if you have any other questions. I hope this makes a little bit more sense.